Hello everyone. In this episode, we want to talk about the cancellation law in group theory. There are actually two cancellation laws. One is called the left cancellation law and another is right cancellation law. They are very similar ideas. So for the left cancellation law, that is if you have three elements in a group G, we call them A, U, and V. And if they have a relationship like A times U equals to A times V, assuming the operation in the group is the multiplication, then we can just cancel out the A on both sides, and we get U equals to V. And similarly, the right cancellation law is for another three elements in group G, and if you have a relationship that U times B equals to V times B, where the B is on the right side of the multiplication operation, comparing in the left cancellation law, A is on the left side of the operation, then we can cancel out the B on both sides, and we get U equals V as well. So those are the cancellation laws for a group. And we can prove that a group always have the cancellation law when you do the operation. So just a proof. Okay, so to prove this, we can, because the proof for left cancellation law and the right cancellation law are basically the same. You just the only difference is the position of the element. Like for the left cancellation law, the element you want to cancel out is on the left side, and the right cancellation law is on the right side. So I just do the proof for the left cancellation law, and you will know how to do the right cancellation law proof. So for the left cancellation law, for those three elements, if we have the relationship like this, AU equals to AV, then because A is an element of G, and we know by the definition of groups, every element in a group has an inverse element. So we know that A inverse also in G. And because we have A inverse, we can multiply A inverse in this equation on both sides and from the left. So that is A inverse times AU, that is equal to A inverse times AV, and then we just use the associative law. Then that is A inverse A U equals to A inverse A V. And here A inverse A is just the identity element E. We can call it E. Here as well, this is the identity element. So the identity element times U is just U, and the identity element times V is V. So we get U equals V. So that is what we want to show, U equals V. And the right cancellation law is same. We just need to find out the B inverse and multiply B inverse on both sides, and it will cancel out the B. Okay, so this is cancellation law in group theory. And another thing is the unique solution for linear equation in groups. So that has a similar idea as the cancellation law. So the properties like this, if we have a equation like this, ax equals to y for some a and xy in a group G, this is just a linear equation. We have saw a lot of linear equation in middle schools about real numbers, about rational numbers, but here we generalize the idea of linear equation over groups, not only real numbers or rational numbers. So we know that for linear equation in because if we consider x is the variable and y is the certain element in G, then similar as in the real numbers, we can get a unique solution for x in this equation. So how we do that? The idea is very similar as we did in over the rational numbers and the real numbers in middle school. That is, we can see we want to prove. So if ax equals to y, then since a is an element of G, then we have A inverse in G as well, just as we showed above in the cancellation law. And we use the same method to multiply A inverse on the both sides of the equation. That is A inverse times AX equals to A inverse Y, and this is just A inverse A x equals to A inverse Y, which means x equals to A inverse Y. Okay, so here this A inverse Y is a solution for x, and because A inverse is an element of G, we find it from G, and Y is also an element of G. So the multiplication of two elements in the group is another element in the group. So we found a solution for x. And now we need to show that x, this solution is the only solution for the equation. And this is true because according to the property we introduced in previous episode, we showed that the inverse of any element in a group is unique. Okay, we showed this in previous episodes. So this means that this A inverse is a unique element in G. So because A inverse is unique and this Y is a certain element in G, so there the operation over those two elements will be a certain number in G. So that means x is a unique element in G. So the uniqueness of the solution x is a natural result of this property we proved in previous episodes. So this is how we proved this linear equation has a unique solution. And this can be very useful property in group theory when we are doing a lot of works in the future. Okay, that's all I want to talk today, and thanks for watching. See you next time. Bye.